Hello, welcome back to A Boring Revolution, your number one news source for everything in regards to the Boring Company. I'm back to you with another episode today. Really important episode. A lot of people have been requesting this particular analysis of the TBMs, what's going on in Las Vegas, what happened in Hawthorne, what's going to happen in the future, maybe in Washington, maybe in California. So this is that episode. We're going to analyze the TBMs, look at the particular differences between them in terms of the techniques and the technology that they're going to use and how this technology is going to scale. So let's start by basically talking about TBMs in general and the Boring Company. So as the Boring Company refines tunneling technology, the TBMs will rapidly evolve. Godot Plus is version 0.6. So this is not actually anywhere near where the technology is going to be in the next 3 to 4 years. We're nowhere near. This is just the initial iteration of the technology. Very minor improvements based on what they used at the Hawthorne test tunnel there. There's no monumental improvement, but there is definitely a machine there that is very, very capable and has proved itself in Las Vegas. However, there's going to be big improvements because Prufrock is a whole different beast from Godot Plus. Absolutely complete different type of systems than what we're seeing today. So let's talk about those key components because they are very different and it really is chalk and cheese. It really is. So first of all, Godot Plus. So this is the machine that is currently being used in Las Vegas. This is the machine that's going to be used in the Resorts World project and in the Wynn Encore Casino project as well. It's a good machine, it's a capable machine, it's proven itself, it's reliable. However, it's not doing what we need it to do in terms of beating that snail, in terms of cutting cost, in terms of rapid progress. So number one, sequential mining method. It's sequential. You're doing the things in various order, therefore you have a critical path. Therefore, things are getting there's only one way of doing it. Basically, you can't do continuously assemble the segments and also thrust forward. That is not what we're interested in because the Boring Company wants to massively improve the speed. Sequential mining is not the way forward. The thrust cylinders work as one whole entity. There's no different tasks for different cylinders. It's all one entire process of thrusting the machine forward via the ring beams. Or the segment rings, my apologies, segment rings. So standard rectangular concrete segments. So that's kind of a universal system of building tunnels. You have these segment rings that usually consists of 7 to 9 segments, and they're all rectangular, and they produce this kind of flat edge which you can thrust from using your cylinders. So it's semi-automated concrete segment erection. Again, there's someone involved in the process. In Godot Plus, there is definitely that element of where it picks up the segment and it guides it into position, but the final process of actually dropping it in there and then connecting it, bolting it together, that is done via persons in the tunnel. Therefore, it is still semi-automated. There's still people involved. Therefore, it is relatively slow. So that is using your erector, or some people call it the manipulator, which picks up the segments. Requires a launch pit and a reception shaft. So you've got to have basically a deep hole in the ground to start your TBM and a deep hole in the ground to receive your TBM, which can be very costly depending on how you build them. Are you going to use secant piles? Are you going to use sheet piling, and then you're going to make an opening for your TBM? There's various ways of doing it, but they are all essentially very costly elements of the construction process. Number 5, manual muck removal and supply system. So at the moment, the process of feeding materials into the TBM and removing spoil from the TBM is managed by people. They decide what is important and when during the process of construction. often you have people driving the actual segment trucks as well. So again, it's a very manual process. It's fairly slow as well, and it's not ideal for breaking records. It's a very atypical way of doing it, and that's how most of the construction industry in terms of tunnels operates. TBM operator, essential to progress. So you have someone who sat in the, as it were, the control room in the TBM, and he's operating that TBM. He's ensuring that it's going forward, it's following its sequential path, and that the various parameters are being met in terms of the pressure inside the excavation chamber, and all this data and all these kind of common sense procedures are manned by either a person or a group of people. And it's a very, TBMs have been done like that for 50, 60 years. There's always someone at the head there who's manning the process, who's making the decisions, who's using his own experience to bore. That's not too bad. I mean, it's not a huge thing. It's not a massive problem if you've got a very good machine. But again, if you can get rid of that person, that's saving you cost. And also all that data that's coming into the system. There's only so much data that you can put into your head at any one time, and things can change very quickly. Therefore, it's probably better that that gets handed over to someone or handed over to a piece of equipment that can make decisions instantaneously rather than waiting 20-30 seconds to analyze the data. Just to summarize, Godot Plus is a good machine. However, it is slow, tedious, and it has intermittent process up to a maximum of 30 meters per day. It's actually never hit 30 meters per day in Las Vegas. It's around 26 to 28 meters per day in that kind of bandwidth. So it's a good machine, no doubt that it's done well for the Boring Company, but again, slow, tedious, and intermittent progress. Here's our machine. Here's Godot Plus. Looks fairly standard components. Not much to say about it really. It is a TBM. It does what it says on the tin. Prufrock. Prufrock is a very important machine for the Boring Company. If Prufrock is not doing what people are saying it can do, then this is a big problem for the Boring Company, because they've based their entire business plan on Prufrock hitting those big numbers. So how is this going to differ from Godot Plus? Big differences. Continuous mining methodology. So the machine is continuously erecting segments. Every sort of 10 seconds a segment is erected consistently throughout the day, maybe even every 7 seconds you've got a segment being erected, depends on the size of the segments. What that means is that the thrust cylinders are broken into two teams, as it were, and some are thrusting and some are withdrawn, and then some are thrusting and some are withdrawn, and it's constant progress. So the machine is basically, it's not 100% continuous mining. There's going to be maintenance periods. There's going to be periods when you might not have enough material. There may be periods where you need to adjust the machine because you're turning. But you've got 60 to 85% continuity. So you're using that time really, really efficiently. At the moment, the current TBMs, I believe just off the top of my head, they spend 5 minutes digging and then the other 55 minutes actually doing various other processes. So that's not good. You want to be spending 60 to 85% of your time digging, and then most importantly you can do all the other processes simultaneously. 2. Hexagonal concrete segments. What that allows you to do, it allows your thrust cylinders to be broken up into two teams, and when one is thrusting, the others are basically stationary or withdrawn, and then it's role reversal. So you've got that constant mining. 3. Fully automated concrete segment erection. So the actual process, so you have a conveyor belt that feeds segments to the front of the machine. The erector is controlled totally by the TBM itself. There is no input from anyone. It picks up that segment. It knows the exact number of that segment. It knows exactly where it needs to go in the tunnel. It can see where it needs to go, and it drops it in there locks it in place. It'll have possibly some kind of click and lock system where the actual segments go into one each other, they lock into place, and there's no need to bolt them together, as it were. That'll be fully automated and fully controlled by the actual TBM itself. Number 4, porpoising TBM via a cradle. So as we've seen from our recent pictures of the TBMs in California, that is looking like their test site there, the actual Prufrock is sat on a cradle, which allows them to enter the ground at a 1 in 7 gradient. This is also called the ultra rapid underpass method. Porpoising is an interesting term, but I prefer URUP, Europe method. Again, that saves them a ton of money, it saves them a ton of time as well, and it also simplifies the process and removes the need for subcontractors and some other specialised construction teams and operators. Automated muck removal and supply. So it looks, although they haven't actually said this, that there's going to be some kind of conveyor belt system in the tunnels which is going to remove our muck. We're going to have trucks that are constantly feeding segments to the actual TBM. I anticipate the TBM may well be extended, it'll be a longer TBM, and the reason for that is that they'll be able to feed more segments into the TBM. There'll be a large storage area where you've got your segment conveyor belt, and all your segments are on this conveyor belt and they're being fed to the front of the machine for assembly by the erector. Again, this whole process is fully automated. The trucks know when they need to come into the tunnel. They know how many segments they need to deliver to the TBM every sort of 10 minutes. How many segments do I need to deliver this time? I need to deliver 40 segments, 50 segments, 60 segments. How many do I need to drop in? They go in there, it's picked up via a mobile crane, dropped onto the conveyor belt, and then you have a large stack of maybe up to 40 concrete segments, maybe 30 concrete segments on that conveyor belt, ready to be assembled at any point in time. Fully automated TBM. So as I've said, there's a lot of data coming back from that TBM in terms of, you know, how easy is it to rotate the cutter head? What is the pressure like in the excavation chamber? All these different points of data, and it's all well and good if you've got someone in a control room monitoring that and they understand that data, but it's going to take them 20-30 seconds to realize, you know, all these different points of data, how they all correlate with each other, and make a decision. Via machine learning, via a system that is fully automated, it can make a decision in 1/10 of a second. Every time data is being fed in, if it's changing rapidly, it can understand it very quickly. There may be some form of AI in there as well in the future, who knows, but I think at this moment in time it's fair to say machine learning will be used. As it's boring these tunnels, it will learn, it will become more competent, it'll become faster, it'll understand the geology, it'll become a better geologist than, you know, any current geologist that works in Las Vegas, because it will gain that understanding from boring through the various tunnels in there and collecting all the various data points from the tunnel. That's an important feature. So just to summarize, that'll lead to a fast, streamlined, consistent progress 24/7, potentially up to 230 meters per day. So that is 1 mile per week, which is what's being quoted on the Boring Company website. There's no other way of doing this. What I've listed here is how it will be done. There's no doubt about that. Absolutely no doubt. And the Boring Company is very clearly stated that these are the ways that they're going to do it. The only thing they haven't mentioned is the hexagonal concrete segments, but I think that is a given. I'd stake my reputation on that, but then again, who knows, they might have some kind of other ingenious method. But I think that's the safest, easiest way to do it. 230 meters per day might seem like a lot. It is a hell of a lot, yeah? Incredible amount. That would be very impressive, but the Boring Company is not going to stop there. They're going to go on and make big improvements. So this machine, which is Prufrock, is currently version 1 of their TBM. It will not stop at version 1. There'll be a 1.2, 1.4, 1.6, version 2, 2.2, version 3. It will constantly evolve. There'll be continuous improvement. Here's our Prufrock up here, top right hand corner. But there'll be more machines. There will be, and this is a bit of a guess, but I like to speculate, there will be a Prufrock Plus. They will further simplify the design, and it will be built to scale, as in they will build it in large numbers, or large numbers compared to existing TBM. So maybe they'll manufacture 4 or 5 machines every month, maybe 10 machines a month, who knows. It will be almost like a mini alien dreadnought, as it were. Hopefully that'll be built in California, but who knows, maybe in Texas. Texas would be a good place for a TBM dreadnought factory. There'll be incremental improvements all the time, every week, and that will lead to continuous improvements and further iterations of the machines. So I have lots and lots of different versions of Prufrock. So Prufrock Plus Plus, Prufrock Plus 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 Plus, and of course Prufrock Plus 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 Plus. That potentially could lead to 600 meters per day, potentially. I think that is going to the limits of what is possible with a TBM, in my personal opinion. 600 meters per day, it's very impressive. I think if you wanted to get more than that, you're better off using more TBMs. But I could be wrong, because the Boeing company have said they want to get close to 7 miles per week, or 1 mile per day. That's incredible. I personally don't think that's possible, but hey, who am I to doubt the Boeing company, Elon Musk, and of course Steve Davis. So thank you everyone who has joined us on this video. Thank you to everyone who has been asking and emailing me to do this video. Very important video. I think the timing of this video has been excellent because the name changes have come, so it's very relevant. As you can see from my summary, you know, there's a lot of areas there where the Boeing company is gonna eke out those performance improvements and get that, you know, 5, 6, 7x improvement in speed easily, and it's very doable, very doable. So please like and subscribe, join us on Discord, Twitter and Instagram. I'd appreciate some feedback. Let me know your opinions, and thank you to all my Patreons. As always, appreciate your support. It really does help me and help this channel, and I can't really, a big thank you from the bottom of my heart for all your support. It's really important to me and I do appreciate it. Thank you for watching everyone. Please like and subscribe. Thank you for commenting. Excellent, excellent, great guys. Okay, so another episode down, really important episode this, and I'm glad you joined us on this one. So let's call it a day. Wow. So let's do it guys. Thank you very much. See you on the next one. And don't be boring. Thank you. Goodbye.